Lord Jesus, Numbers 6 verse 8, the Shema, it's embedded in the doorways of every Orthodox Jewish home and business. What is it? Hear, O Israel. Hear, O harvest. The Lord our God, He is one. And thou shalt love the Lord your God with all of your heart, soul, say it with me, mind, and strength. I pray this morning, Lord God, largely an academic exercise, but I pray by your grace, when everything is uncertain outside of the sphere of God's word, within the trust of the love letter that you have left us, there's peace. And foundational peace, Lord, I believe is in short supply these days. And we at Harvest are rich in it. Namely, we have your word in our laps. And like Paul said, when we can behold your glory, even the deep and eternal things by what you have made, I pray this morning that you use this instrument, Lord God, to get through what I believe are some powerful, powerful reasons to believe God's word over the newspaper, over the 6 o'clock national news, whatever it might be, and over all the fears and paranoias that can grip a culture. For God so loved the world that he gave his only Son. Whosoever believes in him will not perish, but have everlasting life. I believe, Lord, the everlasting life begins on this side of glory. When the fear subsides, when the faith rises, and when we see your face, Lord, before we see any headline. Oh, in Jesus' name, Lord, open up our eyes that we may behold you today. In Jesus' precious name, amen. First slide, are you ready? Last week we started here. This is a brief representation of how the Bible lays out time. There is eternity past. We don't know a lot about before Genesis 1:1, but there was. God says, oh, by the way, I've always existed. And then all the way to Judgment Day at the other end, there is Revelation chapter 21 and all the things in between. We've seen it before. We've talked about it. Genesis 5 and Genesis 11 give you the lifespans of how long people live. Hey, how did they live almost 1,000 years before the flood? We'll talk about that. Perhaps not today, but soon. But anyway, after the flood, it goes down to about where we are today. And then humans begin to behave according to their actuarial tables that your life insurance company is based on. Adam to Abraham, about 2,000 years. Abraham to Jesus, about 2,000 years. What's today's date? 2020. So we have an approximation of 6,000 years. Why is that? God gave us a model. 6 days he worked. What did he do on day 7? He rested. Because he was tired? Wait a minute, I thought he had all power. No, he didn't rest because he had to. He rested because it was a pattern. You work 6 days, what do you do the 7th? You rest. With the Lord, a day is as 1,000 years, says the book of Peter. And 1,000 years is as a day. So 2,000, 2,000, and 2,000 equal how many? 6,000. We've been travailing for 6,000 years, if you will, 6 days. The millennial reign of Christ is a 1 millennium, a 1,000-year period of rest. Planet Earth is restored to its Eden-like condition. The devil is put away with all the demons. They're new-bodied believers, you and I, who got our new body at the rapture. We're ruling and reigning with Christ through that time. At the end of that 1,000-year reign, you will have totaled 7,000 years. Does that make sense? Does it flow according to a biblical pattern? Of course it does. And then, of course, the rapture and the Great Tribulation, which we'll spend more time talking on later. Now for our exercise this morning. Now, all this, of course, goes out the window if the earth is 4.5 billion years old, not 6 literal solar days in creation. And if you spend much time in academia, you almost get the sensation, the feeling that science equals right and religion equals fantasy. I believe there are some compelling reasons that the earth is not billions of years old, neither is the universe. We'll go quickly over the first part because we did so last week. Go to our next slide. There's planet Earth. How old is Earth? Well, how old does she look? She looks pretty good to me. Well, how old is it? Well, that's the thing. Hit our go button. What if you were to walk into a room and you see a candle burning? Now you see the candle burning, and observable science, go ahead. Observable science is the science that you can see it, you can measure it, you can test and even repeat. So observable science is very important. Newtonian physics, special relativity, those are all things that are being more and more understood by really smart men and women. Observable science is very important. It helps us build a space shuttle, an iPad, and of course, the soon-to-be Las Vegas Raiders. All of that stuff, all the blessed stuff in the universe. Well, based on these more or less 3 different principles, that's how we can figure out how stuff works. Now, if you walk into a room and you see a candle burning, the question might be, well, how long has it been burning? Will observable science give you that answer readily? No, because we don't know how tall that candle was when it started. Now we can measure it and we can realize that it's burning at a more or less constant rate. Well, that we can measure, and we can measure how long and estimate before it burns to the bottom. But what you don't know is nobody was there, let's say. How long has it been burning? What if it was that tall to begin with? Well, then it was lit relatively recent. What if that candle is 23 feet tall? Well, it was lit a long time ago. Which brings us to the other portion of science, which many people are a bit more uncomfortable. Go ahead. That's historical science. Eyewitness accounts are important, but eyewitnesses, even sometimes, they aren't as accurate as you might think, especially if they collaborate their stories. Number 2, historical documents. That's important. And then number 3, you compare what the historical documents say to what is observable. If I read an article that said gravity doesn't work in sparks, and I read that somewhere and I live on the East Coast, that may be a document, but if I go to sparks, is that the observable truth? Well, it turns out gravity really does work in sparks, some places more than others. So go ahead to our next slide. So let's go back to planet Earth again. Well, how old is it? It's kind of like we've showed up and a candle's burning. How long has it been burning? Go ahead. Well, let's look at the observable things that can be observed and what is the historical. Go ahead to our next slide. We did this last week, but I'll go over it briefly. There's a satellite picture of Israel. Hit the go button. And there's the Dead Sea. Hit the go button. We know from observable science that it's 31 miles long, 9.3 miles wide, average depth of 653 feet. How do they know that? Because they've sounded that lake. They know exactly the contours of the bottom of the lake. So from that extrapolation, they know that within that body of water, there are 27 cubic miles of water. Hold on, this is going to get somewhere, hopefully pretty quick. Now, from the north comes from the Sea of Galilee, then the Jordan River drains into the Dead Sea, but nothing ever drains out because that's the lowest place on the planet. When you're at the shores of the Dead Sea, you're 1,400 feet below sea level. It doesn't go anywhere. And that's why it contains a content of 33% salt. Where does the salt come from? Hit our go button. This is the water cycle. Hey, we got to see. There's Gladys. Hello, Gladys. She appears to be on a flotation device of some kind, but she's not. She's floating on the water. But because there's 33% salt, that makes her mass pop up because the viscousness, the thickness, if you will, of the water is more so. Hit the go button again. Let's go to the beach. Doesn't that look good? That's not sand. That's salt. Hit the go button again. Where does that salt come from? It comes from the water cycle, which is closely akin to the motorcycle. Isn't that right, Papa Sal? That's right. The water cycle, what happens? The earth is heated by the rays of the sun, and in the ocean, it evaporates pure water, pure H2O, and then it lifts it up, and then the prevailing currents take that suspended water over the land where it condenses in the form of rain and snow. It's deposited on the land and then rushes down the slope of the land into the valleys, and while it does, it picks up salts and sediments and then drains them into the ocean, and that's what the cycle happens. Back to the Dead Sea, why is it so salty? Because of all the salts and sediments that flow into the Sea of Galilee and then through the Yarmuk River and some of the other tributaries of the Jordan, By the time it dumps into the bottom of that little pan right there, same thing is happening. Real water is being evaporated out and leaving behind the salts and the sediments. Here's the point. If there's 27 cubic miles, is that a measurable volume? Yeah. And if you put a device at the mouth of the Jordan River, you would have an understanding of how much salts are going into the Dead Sea. Does that make sense? And so when you take 33%, and is the Dead Sea getting saltier or less salty? Saltier, which means in the past it was, well, then do the math. It's a relatively simple thing to do. How long would it take 27 cubic miles at a known rate, like that burning candle, that known rate of salts and sediments, how long would it take to get 27 cubic miles, 33% salty? Just take a wild stab. Between 5 and 10,000 years, not millions. Go ahead and go to our next slide. Let's take the pool out a little bit more. There's planet Earth again. Let's suck out all the water. Go. There it goes, all gone. Now notice that there are definable ocean basins. There are rifts and valleys and shallow spots and continental shelves and what have you. How do they know that? Satellite imagery and tugging sonar arrays behind you, we know the depth of all the ocean places. The deepest part of the ocean, Mariana's Trench, a little over 5 miles. So if you will, the Dead Sea is a smaller version. Could you do the same thing here? It's a mathematical understanding. Let's put the water back. Go ahead. Then look at all the salts and sediments going in through the rivers. Go ahead. I've cited a few here. This is from a table. This is Wikipedia, by the way. And we all know how perfectly accurate that is all the time. But by and large, let's just take a couple samples. The largest drainage system on the planet is the Amazon system. And at the delta going into the ocean, 209,000 cubic meters per second. There, sometimes it's more, sometimes it's less, but let's call it an average. Number 2, number 3, you'll see, look at the mighty Mississippi. It's only 15th on the list. It's huge. It drains much of northern North America. But look at it. It's on average 16,800 cubic meters per second. And then some other noted ones, the Indus River, only 6,000. And look at the Nile, the mighty Nile. On average, 2,830 cubic meters per second. This list extends to over 150 rivers. Do we know the approximate volume of all the oceans if we know where the bottom is? Yes, it's a mathematical feature. Do we know a pretty good approximation of how much salts and sediments are pouring into these oceans on an average? Yeah. Wouldn't that be a mathematical equation? Maybe not exactly, but it's close. Remember when we walked in on that candle? If we knew how tall that candle was when it started, wouldn't it be a mathematical exercise to come in and find it this tall, knowing the rate at which it burns? And if we knew the exact title or height when it got started, we could tell you when that wick was lit. Does that make sense? Well, the ocean on average, go ahead. On average, the ocean is 3% salty. Now, some places more than others, but on average, 3%. That's a known volume of water. That's a known rate of salts and sediments going into a finite system, a known volume. Go ahead. At the current rate of salts and sediments going in, how long would it take this ocean basin to become about 3% salty? 4.5 billion years? Now, how long has the water cycle been happening? Long time. No, the answer is no. What about a billion years? No. What about 50 million years? You know what the math is? Go ahead. 5 to 10,000 years. And some of you are going, nuh-uh, yeah, huh? What are you saying? Have you ever heard, well, the whole idea of a universal flood is stupid because if God flooded the entire earth, that would deluge the saltwater species. Saltwater crocodiles and animals and sharks couldn't survive. Ha! You stupid Noah's Ark people. Wait a minute. When God first created the universe and created the heavens and the earth, would it seem logical that the oceans would be salty when it got started? The reason it didn't kill the salt species of the ocean with fresh water of Noah's flood is because all the water was fresh then. You could hear a pin drop in the whole place. Now eventually, over about 5,000 to 10,000 years, those species have adapted. Aha, you've just cited evolution. Please understand, when Charles Darwin first observed the finches on the Galapagos Island, he noticed there was some differences within the species. I simply point to our large dog, Bear, who is 170 pounds. Oh, yeah. Try to feed that universal black hole. And are there smaller dogs than that? They're really tiny ones. Aha! Breeders can, through genetic probabilities, Gregor Mendel, how many of you had to plot your tables with Gregor Mendel, and you thought, I hate this, I want to go play in recess. He was a priest who messed with snow peas and found out that, there are certain probabilities. If both parents are dark-eyed, then you have a certain probability. The point of it is, you can see a change within a species relatively soon, within a few generations. Here's the question. Can a species radically change so much that it changes from one species and becomes another species? Darwin didn't know that. Darwin didn't know about the genome. Darwin didn't know about the 3/4 self-correcting code that is DNA, deoxyribonucleic acid. He looked under the microscope and saw blobs. He had no idea that every blob was a machine. Specifically, if you take out, they're so small, you take out one component of those little machine and it doesn't work. It's like a mousetrap. I have my board, I have my spring, and then I have a trigger. If I flick the thing, the trigger comes off and you got yourself a mouse. I take away the spring, does the mousetrap work? If I take away the board underneath, does it work? If I take the cheese at the end of it, does it work? The point of it is irreducible complexity. Your cells are full of them. They have little machines that if one of many components is suddenly absent, it doesn't work. The eye, it's an evolution. Seriously, how many mechanism, lens, iris, vitreous humor, the nerves that work with it, that is a system, a machine with components that work in the same direction to make the machine work. A system does not evolve with chance mutation. Are you okay with that? All right. So, what about speciation? I think Darwin was an astute observer. Because of the food supply, the beaks of the finches noticed some change. But here's the point. They didn't become another species. And nowhere in the fossil record can you find a definite species, a transitional species, and then the new species. And some of you already are lining up the skulls that go from Australopithecus africanus. How about that? They go all the way to Homo sapien. I'm going to talk about that in a minute. Back to our study here. About 5,000 to 10,000 years. How do you explain only 3% saltiness if the earth has been around for 4.5 billion? It cannot be more than a few million. It cannot be more than a couple or more than 100,000. It's, in the estimation of the studies I've seen, between 5,000 and 10,000 years. I say about because of the deluge, 6,000 years plus the deluge. So I promised I wasn't going to go into these things, but I'm going into them, aren't I? Go to our next slide. Let's see what else we got. We went over these very quickly. There are biological evidences. Remember, you've walked in on the candle. You see a candle burning. You know how thick the candle is. You know how tall or what remains, but you don't know where it started. and you don't know who lit it and when. Observable science is going to be helpful to some degree. Let's check this out. Biological. There are countless fossils that are not fully mineralized. Petrified trees and dinosaur bones are not bones, and they're not trees. What happened was they got covered over very quickly, and then they happened to lie in a mineral-rich sort of soup, if you will. And these minerals, especially silicates, leached in or were drawn into the fibers of the wood or the bone. And then the calcium of the bone was eventually replaced by these silicates. But the biological structure, like a form of concrete, formed the silicates in these manners, and it looks like a bone. So what about all the skulls when you're driving east of Sparks? Is that going to become a fossil? Answer, no. Why? Number one, it's not buried, and it's not in a silicate-rich environment. That skull is going to be eventually beaten down by the rays of the sun, and it's going to eventually then go to dust. Well, then how did the dinosaur bones become dinosaur bones? Yeah, good question. They had to be covered over quickly, instantaneously, in silicate-rich sediments. Does that sound familiar? What might do that across the surface of the earth? Maybe a great deluge, a great flood? But back to that, we find many bones that aren't fully fossilized. There's still DNA in some of them. I cited Dr. Mary Schweitzer, University of North Carolina, found blood cells and soft tissues in T-Rex specimen MOR 1125. You have your Triassic, your Jurassic Park. I almost was going to sing the thing there right there. Do, 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 do. No, I'm not going to do that one. And then you have the Cretaceous, and T-Rex is at the end of the Jurassic and into the Cretaceous. Well, conservatively, 150 million years ago. How long can DNA survive? Not millions of years, not hundreds of thousands of years. A couple thousand at best. Why are there DNA in some of these fossils? There's the decay rate of the human genome we talked about last week, mitochondrial Eve. Your cells have a nucleus. Your nucleus have chromosomes made up of molecules, the DNA molecules, and they're pretty amazing. As I said, it's a 3/4 self-correcting coding system. You're a good thing, too. 400 trillion cells in the average human body. Some of us have more cells than others, but every one of them are replicating, and how that happens is quite complex. We better be glad that on average, our DNA replicates itself quite fine, thank you very much. What happens when it doesn't? Then you have a cancer cell. Although some of us have battled cancer, as a rule, most of us haven't. How's your DNA doing? It's doing pretty well. Why? Because of a 3/4 self-correcting formula. Does that sound like that could have arose out of happenstance? Or does it sound like there is a designer? Fossilized trees transecting coal layers. We talked about that last week. Non-fossilized trees and old rock strata. The oldest living things are under 10,000 years old. Why is that? Why aren't there living things, even systems like the Great Barrier Reef out of Australia and so on? Why are they on average less than 10,000 years old? Why aren't there ones that are millions of years old? Bristlecone pine. Geological. I don't know if we got to this last time. The thick, tightly bent strata with no fractures. You can see some of those layers on the way over to Lake Chilkoot. What's the lake out there? Frenchman's. And you're cruising through some of the metamorphic rock layers, and you'll see folds and even curlicues. If rock strata is laid down by sediments at the bottom of the ocean, the theory says it takes jillions of years for it to harden under pressure and sometimes heat. And so the folding and the bending of the layers and the up thrusts and the down thrusts and what have you are because of the plate tectonics. That makes logical sense. What happens when your rock strata does this? Boo! Did you like that, Chris? Is that a geological term? And that means that they got folded and they got curlicued before they had a chance to set up as rock as we know it. That's the point. How do you explain those things? The Kaibab upward in Grand Canyon indicate rapid folding before sediments had time to solidify. Oil pressure. In the old days, when you'd punch through to a reserve of oil, what would come gushing out the top? Oil. It's a blowout, gusher, you know. Why does it do that? Because of the pressure. All rock is porous, some more than others. If it's billions of years old, that pressure would have neutralized. Why is there still great amounts of pressure? Arches National Park, Utah, we saw last week, there are over 2,000. Since 1970, 43 have collapsed. Okay? So if just one of those a year, how many do you have? You could go back maybe 2,000 years. And the Arches National Park, conservatively, is hundreds of millions of years old. It can't be. There's too many arches that are still surviving. Rapid canyon formations, we pointed out Providence Canyon, Georgia, et cetera, radiometric dating. Let's go to the next one. Go ahead, go to our next slide. Radiometric dating. Carbon-14, what's that? The rays of the sun break down nitrogen into various isotopes. We're not going to go into exactly what an isotope is, but I told you I'm not going to go over there. So what it is, it's a subatomic particle, and many of them are radioactive. And so carbon-14 is one of those. So the carbon-14 is then condensed into form of rain. It goes into the earth and comes up as the plants absorb that. Then the carbon-14 is in the plants, and the animals eat the plants, and sometimes humans eat the animals, et cetera, et cetera. So there's carbon-14 everywhere. Carbon-14 jumping off all up in here. Lots of carbon-14. Carbon-14 in a perfect laboratory setting has a very defined half-life. It breaks itself down over a stable period of time if the environment is stable. What's the theory? Animal ate a bunch of carbon-14. The more it eats, the more concentration of carbon-14. Then when it finally dies, it's not metabolizing carbon-14, and then it lays and becomes a fossil, et cetera, et cetera, et cetera. We take one of those, put it into the carbon-14 machine, and we have a bone, say this big, and we have these actuarial tables as to how much carbon-14 when it was alive. Well, how much is left? There's only this much left. Simple math. That thing is 50 jillion years old. Okay, here's the point. Carbon-14 is still filling up in our atmosphere at quite a rapid pace. What do you mean? If I have a bucket, water in the bucket, I have a hose in the bucket, and I have a hole in the bucket. If the water going into the bucket equals the hole at the bottom, what happens to the water level inside? It stays the same. If one of those are off, then it'll change. Carbon-14 is still filling up in the atmosphere, which means in the past there was less. I'm going to leave that one alone. Let's just keep cruising because there's some more I want to get to. This is fascinating. How many of you love helium in your balloons? You go, you sound really funny and your kids laugh at you. It's pretty cool. Who manufactures helium? Well, the Walmart does. Have you noticed in the last 10 years, helium has gone up 250% in cost? Why? Humans can't make helium. What? Well, you can get it in these big tanks, I know. You know where it comes from? Did I write it down? It's a byproduct of radioactive decay of uranium and thorium. Where does that happen? It happens under the surface of the earth. And it arranges itself usually around pools of natural gas. Helium is mined out of natural gas deposits that come out of the ground. Turns out America is the Saudi Arabia of helium. Did you know that? We got helium. And the thing about helium is once you let it go, it's the second lightest element in the universe. It just floats right away and then is dissipated at the end of the edge of the atmosphere. Once you let a helium whatever go, you're not going to get it back. Helium is getting less and less and less and less abundant. Fascinating. Well, when molten magma and pyroclasts and what have you of the volcanic side, when they lock up into a crystalline substrate, if you will, rock, helium gets trapped inside. And by the amount of helium that is found in most granite reserves, it's off. So effectively, when that mountain formed into igneous rock out of liquid rock, the helium amount got frozen inside. So when you chip it away, you can put it theoretically under a microscope, or actually, would that be a colorimeter? She said, don't, the geologist is saying, Steve, stay in your lane, dude. Just stay in your lane. You know what you're talking about. You break it down, you can find out what elements are inside. And so when you do that, it's off. If we cannot manufacture more helium, that means the helium on planet Earth is getting what? Which means in the past there was, and that dipstick of how much today helium is 5.2 parts per million. And in the past there should be more. And then you look in the rock, the helium frozen in these rock deposits, and it doesn't add up. And if you want to do a rate, it's not hundreds of thousands of years. Guess what it would be? 5 to 10,000. How much time do we have? I got 50 minutes to bore you to tears. Are you ready? Let's just keep cruising. Let's go to astronomical evidence. Go to our next one. We talked briefly about it. The moon is getting away from us at the rate, the cruising rate of 5 centimeters a year. So if it's moving away, that means in the past it was how much closer? You can't be billions of years. It can't be millions of years. Well, not hundreds of millions of years. And the sun is shrinking at 5 feet a year. Everybody loves uniformitarianism. That's the engine that makes indefinite periods of time and random selection that moves from species to another species, or if you will, organic evolution, requires jillions and jillions and jillions of years. Why? Because it's an X factor. You can't replicate it in the laboratory. You walked into the candle, and then you make a huge supposition of how big that candle was. So if you were operating, that candle must be 20 feet high when it started. Nobody knows because nobody was there. Well, Adam was there. But if you start from the supposition that candle was 50 feet tall, you see how it works? The observable science begins to become a little weird. At shrinking at 5 feet a year, it's getting smaller and smaller. Here's planet Earth, 93 million miles away. It's getting smaller and smaller and smaller, means in the past it was what? And if you go hundreds of millions of years, not billions, hundreds of millions of years, then we, planet Earth, are sitting on the sun's surface. Is everybody okay? Sediment levels on the lunar surface. That was an interesting thing. We know on average the debris that's coming in from space, literal little tiny little baby little things, dust to us, but they're fast movers. We have an atmosphere thick enough that if they're going fast enough, the friction burns them up. But because of our satellites and understanding, we've taken measurements. How much sediments are raining in on the Earth per year and per annum, what have you, we know that approximate amount. And when Apollo 11 was getting ready to land on the moon, that was a real concern. The lunar surface has a minuscule amount of atmosphere. It has some, but practically immeasurable. So what happens to all the sediments piling up, the dust, if you will, on the surface of the moon? It doesn't have an atmosphere to burn it up. Like your window in your house is going to get what? Dusty. Well, do the math. If we've been around 4.5 billion years and we know the rate at how much dust per year, some scientists were worried, rightfully so. Do the math. The dust on the surface of the Earth should be hundreds of feet deep. Let's take a picture. I couldn't help. Here's Neil Armstrong. Go ahead. Yeah, does that look like hundreds of feet to you? I'm just saying. Back to our, go ahead, hit the go button. Let's go back. Real quickly, Uranus, Neptune have magnetic fields that should have worn off by now, if it's billions of years. Volcanoes on Jupiter's moon, that's a real head scratcher there. It's just 10%. So they're belching out, if you will, subsurface materials, let's just scale it back to 10%. If just 10% of the current rate, if 4.5 billion years old, they would have ejected its entire mass 40 times. They can't be that old. Methane clouds in Saturn's moon Titus. Methane breaks down with sun's UV rays. In 4.5 billion years, methane should be long gone. Existence of short period comets. I'm going to skip that one. Halley's Comet, the Yarkovsky effect, predicts, and it's mathematically certain, that near-Earth comets will all be captured by the sun within 20,000 years. Why do we still have close by Earth comets from the Kuiper Belt? Gas giants. That was me the other day. I had some food that didn't agree with me. Wow, you did not want to be around my orbit if you know what I'm talking about. Gas giants, Jupiter 2 times, Saturn 4 times. They radiate 2 and 4 times more energy than they receive from the sun. That doesn't last long. If your gas tank is only so full, you can't be around expending that much energy. You can't be billions of years old. Next, human history. The current population of planet Earth is 7.7 billion people. And again, for those of you in the insurance markets and those of you in statistical sciences, statistics is a fascinating mathematical mechanism. It really is quite astounding. How these actuary tables or bell curves are so amazing at predicting, or I should say cataloging probabilities. They're pretty amazing. So take your actuary tables and apply them to 7.7 billion people. There are more and more people on the planet, which means in the past there was how much less and what is the rate? And these actuarial tables are valuable instruments in predicting just such a thing. Let's take into account wars and pestilences and what have you. The Black Plague, that 1 in 4 humans in Europe died. Taking all that into account, reverse the film. At 7.7 billion people currently, how long would it take us to get here? Take a guess. 5 to 10,000 years. I say about 4.6. All of us have relatives from Ararat. You're going to get that a little bit later today. Get it? We all come from the Ark. Is this thing on? Is this thing on? Just want to see if we all have relatives from Mount Ararat. There's simply not enough people. The length of recorded history. What's recorded history? Pictures and cave dwellings and all the different places and written material. Modern man, theoretically, has been 150 to 100,000 years on the planet. And there's just not enough recorded history or artifacts. Humans cannot have been on the planet that long. There's just not enough. Here's another thing. The length of recorded history, by the way, suggests about 10,000 years. I would say, I'd call it about 6,000. Common cultural myths. We know about the Genesis flood, but so did the plates of Gilgamesh, the Ba'amai, New Guinea, the Adaman Indians in Peru, Chippewa, Ottawa, Choctaw Indians in North America, the Gunyu in China, the Some in Brazil. I could go on. Why do all ancient cultures have a common universal flood myth in their ethnic background? Because it happened. That's why. Not that long ago. All artifacts and records are less than 10,000 years. Stone Age human skeletons and artifacts. Oh, don't get me started, but here we go. Go ahead. This is what we talked about earlier. Next slide. Here is a computer-generated picture of the Big Four. Australopithecus africanus is one of the main left turns out of being an ape. There's the skull. Estimated 2.5 million years ago. Then the next big change is going to be Homo habilis, 2 million years. And then Homo erectus, 1.5. Homo sapien, now we're getting close, but we're not at modern man yet. We're 1 million. You want to see modern man? Here he is right here. Go ahead. Oh yeah, baby. Oh yeah. I don't usually like to take my shirt off, but I will. Actually, that's a Norn Mac right there. I just put my face on it. Modern man is 150, really 100,000 years old. Modern man. Go to hit our next one. I'm sorry about that, but that was kind of funny. Starting at the left, there you have Australopithecus and all the way down to modern man. How many of you remember seeing these in your history books or your science books? Look, there it is. There's those skulls. We found them. Here's the thing. Those skulls have never been found. If you didn't know this, those skulls are approximations of a tooth, a bit of a temple, or a bit of a jawline. Those actual skulls were never found. They are artist renditions, and they come from a presupposition that humans have come from monkeys. Question, why is the missing link missing? Because he never was. Oh yeah, he did. Go ahead to our next slide. Here are some ape men hoaxes. Heidelberg man, 1907, built from a jawbone. Nebraska man, 1922. Henry Osborne from just one tooth. Later, oops, it was a pig. Piltdown man. Now, some of you who've been in, it's been a while since you've been in school, how many of you remember seeing these actual pictures of these actual Piltdown man pieces? And you thought for sure that we went from apes to men. And nobody writes a retraction. Oh, by the way, Piltdown man, psych. I'm being overdramatic, aren't I? Piltdown man, Charles Dawson from a jawbone of a modern ape, 1953, was proven to be a deliberate fraud, had been filed and treated with iron salts. Peking man, 1921, evidence disappeared. Why? Because it was an outright fraud. Neanderthal man, found in a cave in Neander Valley near Dusseldorf. The International Congress of Zoology in 1958 showed that it was an old man suffering from arthritis. Java man, he invented coffee, if you didn't know that. Right on, Mike, right on. There you go, attaboy. Java man, 1922, was a skull cap and a femur and a thigh bone. Yeah, and the teeth were of an orangutan. And finally, let's go to this. What about star distances? Go ahead, next one. How far is our closest star? Go ahead. It's Alpha Centauri. Ding, winner. Our closest star is Alpha Centauri, and it is 4.37 light years away. What does that mean? Light travels at 186,000 miles per second. That's an observable, understandable velocity. So if it takes 186,000 miles per second in 4.3 million years, it will arrive at your eyeball. Does that make sense? Now, how do they know that Alpha Centauri is 4.37 light years away? Have you ever seen the measuring tape that they used? Remember, you've walked into a room and a candle is burning. How long has it been there? Here's how they do it. You might be surprised. Go ahead and hit our go button. So there's planet Earth, 4.37 light years away. How do they figure this out? Here's what they do. Math teachers, you might get a kick out of this. Go ahead. It's called parallax geometry. It's a triangle. We don't know how far it is really, but we do know that in June, planet Earth is on one side of the sun. 6 months later, in December, it's on the other side. Well, that's easy. Hit the go button. 93 million times 2 is 186 million miles from December to June. Do you see where I get that distance? And if you know the degrees of the sides of the triangle, any math teachers in here getting cramps? If you know one distance of one leg of a triangle, and if you know 2 of the angles, this is easy math. Well, easy for you. You're going to find the hypotenuse. And here you go. Hit the go button. And the hypotenuse is 4.37 light years. That's how they determined how far Alpha Centauri is. Now let me put this in perspective. 4.3 million light years would be placing a BB in Carson City. And I'm going to take the bottom part of my triangle 18 inches. 18 inches. I take a measurement of my BB in Carson City, and then I can figure the angle of this leg of the triangle, and then I'm going to move 18 inches over. I'm going to find that BB in Carson City and line it up again and find my angle. If I know this distance and the two angles, finding the hypotenuse is a mathematical certainty. Would you agree with me that 18 inches from Carson City, the BB, how hard would it be to get this angle correct? Now, do we have measuring devices that are that sensitive? Perhaps. But that's at 4.3 million light years. What would the BB look like if it was 10 light years away? Well, it'd be well over the curvature of the earth, and it'd be somewhere in San Diego. San Diego, 18 inches. Would you think it's a fair assumption that anything past, I'm going to call it 10 million light years, or 10 years, if you will, anything past that, in my personal opinion, is a guess to me. Now, there's things called redshift when an object is moving away from you, the Doppler effect. If you beam it with some form of radiation, the waves will elongate a bit. If it's moving toward you, they compress and become higher. That's the Doppler effect. A train, honk, honk, honk. That's the Doppler effect. And if you've had your baby sonogram and you see the red and the blue, that's your heart. And some of it's red, some of it's blue. That's Doppler. Doppler is a very important thing. So based on light readings and what have you, they have an understanding of things moving around. But are you okay with me when I say we don't really know how far these stars are? Is everybody all right? Is anyone shocked? I think it's a guesstimation. How long has a candle been burning? Well, we know that candle is at least 50 feet high when it started. Or do you know that? How do you know that observationally? Answer, you don't. But if you start with that assumption, all of your theories and laws might be affected by it. Parallax geometry, that's how you do it. All right. Now, I'm not going to argue the fact that there aren't great distances between the stars and the galaxies. What about that? Huh, Mr. Smart Guy? Next slide, if you would. Here's a tree. Go ahead. It's a peaceful little tree, and it lives right over here. How many of you ever watched that guy on Channel 5? He's a peaceful tree. Let's put him, what was his name, Bob? Bob Ross. Bob Ross with his big thing. Put it a peaceful. Man, where my mind goes. I don't understand it. Now, if God has the ability to manipulate molecules or even to build them in the first place, is God able to make whatever he wants? Yeah. As you know, this thing is not actually solid. It's the arrangement of certain atomic and subatomic particles in such a way that it feels to me like it's solid, but not really. What's really between all of these molecules? Very strong forces, some of which are measurable, some which are a bit of a mystery, dark matter and what have you. The point of it is, nothing really is truly solid. It really is about forms of energy. Is everybody okay? So if God wanted to make a tree, could he make a tree? Could he make a tree like this? Poof, there's a tree. If he made a tree, would the tree have rings? But there's the tree. Could God make a tree, everybody? Yes. Absolutely he can. So he can make a tree, and in 30 seconds after he made it, how old is the tree? 30 seconds old. Now, if he made a tree, would it have ding? Would a tree that God made have rings? It might. Let's take it even farther. Adam, did he have a belly button? I don't know. We'll have to ask him when we get there. Go to our last slide, and I'll put you out of your misery, I promise. When God made Adam and his height and dimensions at a typical cellular rate from a baby to a large person, we have an understanding how long that takes. But when God formed man out of the dust of the earth and he breathed into it, the man became a living soul. 30 seconds after his creation, how old was he? 30 seconds old. How old did he look? If God wanted to create a universe, could he? Boosh! This whole universe is created. Stars are beaming in, says the fourth day of creation. Well, if these distances are so, then wouldn't it take hundreds, if not billions of years for the light to travel? Is it possible that God could create a universe with apparent age in place? Amen? Do I want to talk about this? No, I don't. Everybody, let's all stand together. You did it. You survived science class. Would you join me in prayer? Lord, it really is absolutely true. People don't understand. In the case of some of the sciences that are trying to discern how old planet Earth is, they don't understand that humans are humans no matter where humans are humans. And if I want to get a grant that I don't have to work at Denny's, and I want to take a theory and prove it on the Olduvai Gorge and find whoever, I have to convince the board who disperses funds so that I can take my 3 years and do my research. There is intense competition for these grants. You have to go into your study likely with a large bias. I know that the geologic column, oldest and simplest elements on the bottom strata, new, cool, advanced species on the top. The geologic column is theory. How old is that rock? Well, it's 4 billion years old. Why? Because of the trilobites we found in it. Wait a minute. I thought that evolution is a theory. Well, yeah, but you're dating rocks by it. Well, how old is the fossil? It's 3 billion years old. Why? Because of the rocks we found next to it. Are we seeing this? God's word says plainly, He created the heavens and the earth in 6 literal days. Perhaps someday we'll talk about the evolutionary process, how that is quite impossible from the standpoint of genetics alone. But some Christians want to balk just a bit, and they say, well, the ages weren't really 24-hour periods. That accounts for the long epochs of time where the evolutionary process could take place. Wait a minute. Day 4, God creates the stars and the sun and the moon. The next day, the grasses show up. Is everybody okay? Long ages don't fit in the model either. Thank you, God, for making the stars, well, you know what it is. Thank you, Lord, that you saw the evolutionary lie coming down the pike. Lord, thank you that you moved the day of the stars' creation and the grasses and the trees. They could not have happened if the evolutionary process were the rule. It's 6 literal days. Why is that important? Because that means God is right. That's why. And that evolution and these jillions of years of age, I've cited approximately 17 today. And I currently keep a list of over 103 reasons, and in my own mind, they're pretty solid reasons why the earth can't be billions or even millions or even hundreds of thousands of years old. It cannot be. I want to thank you, Lord, that because we've taken this time in the science class this morning, Lord, perhaps it gives us more an ability to trust your word when it says what it does. I want to thank you, Lord, for the agile minds you've placed within us all. No accident that you happen to be here today. And I pray, Father, in Jesus' name, that you take these truths. Yep, they're going to find their counterparts on the internet. By all means, jump in, have fun, do your own research, and please keep your mind running. And let me ask you, I've walked into a room and a candle is burning. How long's it been there? Let's look at the observable. And God says, 6,000 years. Get ready. Because the 7th millennia is about to arrive. Are you ready for it? The coronavirus, the geopolitical atmosphere in which we live, the presidential cycle that we're amidst of, a lot of scary stuff, Lord, but not for the one who believes in your word, not for the Christian who knows he or she is saved by the blood of the Lamb, by the finished work of Jesus Christ on the cross. God zipped up a human suit so that you don't have to be afraid, because this life, Harvest, is not the real eternity. The eternity with him is, are you saved? In Jesus' name, Lord, I want to thank you for our time today. And everybody said, amen. Amen. If you got some more questions, come on up. We'll talk about it. We'll see you on Tuesday night prayer.